So this is question 2 of the practice question in Civil 566A. The original author of this question is Dr. Graham Wood in Arab of Australia. So let's read the questions first. So the figure 2 shows a 10 meters pressure above the ground chart for North Europe with pressure in millibar, isobar 4 hectopascal spacing. So this is Edinburgh over there. So first describe the pressure chart, comment on the type of weather pattern and surface wind velocity. So as we can see from the scale of the event, and we should be able to know that this is severe synoptic event. From the scale. And the second bit, the wind velocities. So that requires to state wind speed and the wind direction. And because this is north hemisphere, we know that anti-clockwise wind speed, wind direction, and just briefly comment on the wind speed, so that we can say at where the isobars are dense, that's where the wind speed is high. When isobar is sort of loose, and that's where the wind speed is relatively low. And if you state that, you may obtain the full marks. So then second question, estimate surface mean wind speed and direction at Edinburgh. So direction is easy because we determined that it is anti-clockwise, and the wind direction will be southwest. And surface mean wind speed, so we can use this question over there in a lecture size. So this low pressure center, and this is high pressure center equation. And if we see that this is 1014, 960, and this is, which means this is low pressure center. And we substitute in all the other parameters are stated over there except the pressure over radius. And the hint is over there. The pressure gap between this line and this line is 3 multiplied 4, 12 hectopascal, and the distance is 650, and we can sort of scale to here to obtain the changing velocity. So this is 4 hectopascal, and we can say that distance is 200 kilometers, and we will substitute everything in. We will be able to answer the question. And so here, estimate 3 meters per second gust and mean wind speed at elevation of 100 meters per second. So we can draw graph. So if we draw this x-axis is height, and this x-axis is wind speed, we know from the boundary layer that, so for this 10 meters per second, and there's 100 meters per second, and this is min, and the gust wind speed will be larger over here. And this is 100, this is 10. So then the key thing over there is estimate this jump. Estimating this jump to obtain the mean wind speed. This is 3 meter per second gust mean speed, and then we work backwards. So over there, from Australian standard, we know that gust wind speed equal mean wind speed multiplied by 1 plus GVIH. Not difficult. This is from, you can guess this from the table in Australian standard 1170. And the tricky part is this one, this jump over there. How can one estimate the ratio? It depends on the terrain category. So it's sort of the wind speed, the wind direction asked over there sort of gives a hint. Because if we look at in the southwest of Edinburgh, it goes across the UK. And if we go across the UK, we can sort of estimate it is terrain category between terrain category 2 and the terrain category 3. So we will pick terrain category 2.5 this time, and they give it over there 10 meter per second, 100 meter per second, and the ratio of that is the wind speed over there. And we can overcome this jump, and we will go backwards. That's the same thing, and we will be able to calculate the 3 meter per second, 3 second gust and mean wind speed at 100 meter height. Okay, thanks for watching.